Okay, remember last time I talked about accuracy, precision, and trueness. Accuracy in the new definition is how close the mean of a set of measurements comes to the true value. Precision is how close repeated measurements come to each other. In order for something to be true, it has to be both accurate and precise. Back at the first video of this module, I talked about metadata. I'm moving up now from accuracy and precision to data quality and errors. This is going to be really important with your data. Why is it important? Because data that is of poor quality is like a weak link in a chain. You might have a wonderful GIS that can process things like crazy. You give it data, 9 pieces of data are perfect, but that 10th piece is not good at all, and what you'll end up coming out with on the other end of the GIS is not good at all. So we've got this three-dimensional world, and we're struggling to represent whatever important aspects of that we can using either the vector or the raster model. We're struggling with georeferencing and making 3 dimensions into the flat map. But we get past that, we put all that representation into the computer. Fortunately, if we put garbage into our model, put the garbage back into our computer, we're going to get garbage out the other end. And that's a term, garbage in, garbage out, GIGO. If you ever see that, that's what it means. And so we need to be concerned about errors, because one piece of data that has an error in it is going to propagate throughout the entire set. So here's an example of a bunch of different themes that we have. We have states that look good. Maybe we have state capitals and there's something wrong with that. We have rivers, looks good. We have roads, looks good. We have lakes, looks good. Now we're going to put that together and make a map. But remember, even though all of these things look good, there's an issue with the capitals. And when we do that, the map that we come out with is going to be no good. Garbage in, garbage out. And all of it has to be good for the result to be good. So there's a bunch of types of error. Classify error as one of these many types. Attribute error, that's an error in the what associated with the data. Positional error, the where. All that georeferencing talk was about the where of the data. Topological error, I haven't talked about topology much yet. Topology is how features relate to each other. So there are 3 kind of aspects to topology. One of them is adjacency. You can imagine that as states in the United States. Idaho is adjacent to Washington. Containment is another. All of the cities in Idaho are contained within the Idaho border. And connectedness is another, and that would be like a road network. All of the roads in Idaho are somehow connected to the other roads. Maybe, maybe not. Temporal error is error in the when, of course, and then there are these 2 other types of error called the ecological error and the modifiable areal unit error that I'll be talking about in the next video. Okay, so when we have these errors, how do we know we have them? Well, we have to do spot checking, which means we have data, we need to go out into reality and measure the same thing that we measured in our data and see how close those 2 things are. So we can do it randomly. We can just go out and pick points and measure there and compare that to what our data says. Or we can make a plan. We can make a spatial sampling plan. And when we make a spatial sampling plan, we can do random sampling within that spatial sample. We can do stratified random sampling, cut it into pieces, and then within the pieces do random sampling. Or we can do systematic sampling. So what are these different types of sampling? Random sample says just go randomly into your study area and randomly pick some points. Now that might really work okay if the points that you're picking are representing randomly associated data. But you can see here that there's only 2 points in this part of the study area, and there's 3, 6, 7 points in this part of the study area. So if you do random sampling, you may not be adequately sampling the study area that you're concerned with. So you can do stratified random sampling, and in this case what you're doing is you're saying, well, this study area represents about 3, 5, 7, about 1/3 of the total area. So about a third of our points should come from this part of the study area, so we randomly sample 3 points from here, 6 points from here, so it's stratified, but it's still random. Systematic, of course, is not random, and that would be making a sample every X meters or every Y feet. So 3 types of spatial sampling. Next time I'm going to start getting into these different types of errors and how you try to measure those errors. And then the final video will be about those last 2 types of errors, the other errors.